Welcome everyone to the next talk. It's called Space Django, Migrating and Redesigning a Database While Hunting for Satellites. And the speaker today is Artur Baruchi. I should have checked that first. He has a bachelor's degree in computer science and received a PhD degree in computer engineering from Brazil. He moved to Australia in 2021 and works as a software engineer at Goldman Sachs, and he's currently working as a software engineer at HEO, an Australian startup in the space industry, and as a technical reviewer for books. Please give welcome to
Thank you very much for introducing me. Thank you. So today, just worth to mention, this is not my first PyCon. I had a presentation in PyCon 4 years ago in Brazil, but was much easier for me because I was speaking in my first language, Portuguese, not English. So, it was easier for me at least. Today I'll be talking a little bit about the migration of the database that we had in the place that I'm working right now. It was a project that took place at the end of the last year to the May, April of this year. Something is still running, but we'll talk a little bit about how this migration took place and how we explored some options to do this migration. And, well, if you were looking into that, the presentation title, I said that we were hunting for satellites, so probably you're bugging us, but hunting what? Wait. Well, please don't panic, because we're not trying to start the Third World War. It's a hunting more in the sense of a paparazzi stuff, like you're hunting for Hollywood stars. So we're not trying to destroy or break anything. It's more hunting like that. So we are just taking pictures of satellites. And it turns out that here it's a startup founded in 2016, and it's the first company that is using on-Earth imaging. It means that the sensor camera that is taking pictures is actually attached to another satellite. And why we say that this is a hunting? Because it's really hard to take pictures of satellites. They are really fast objects. They are orbiting, for example, the ISS, the International Space Station, is orbiting at a speed of 28,000 kilometers per hour, so it's really fast. And you also need to make some calculations in order to identify the better time to take pictures of that objects. And both are orbiting at really high speed. So that's why we say that we are hunting, because it's almost like that. So we are hunting the best perfect time to do that. So this is the term hunting satellites. This is some examples of the pictures that we take. Like on the presentation, I don't have this space background. So when I started in this company, I was looking at these photos and I said, well, you probably have some issues in these cameras because you're only seeing blur stuff. And I was, yeah, maybe there's something wrong with you guys because I'm not seeing anything here. But it turns out that soon I realized it's almost the gold standard stuff, and they can actually extract a lot of information from those pictures. It really is, it's amazing. But we also can take really nice pictures of using those cameras. We also have our own hardware right now on satellites, so we can take really nice pictures. So it's not so blur, let's say. So it's really interesting stuff that they are doing there. And this is just an example of report. So given that blur image, we are able to extract a lot of information like this. So the size of solar panels, for where it's pointing to, the sun, to the earth, the angle, a lot of stuff we can extract from those pictures. And this is basically, I would say, not for the main product that we have today that we're selling to the customers, to the guys that are interested in this kind of information. So this is basically to give you a context of the company, because this is important to understand the problem that we are trying to solve. The problem basically is that, well, if you came to me, or any software engineer say, oh, I need to build, I don't know, a web application to sell products. It's pretty straightforward. You know, hopefully the features, you're going to have customers, you're going to have products, you know, all this stuff. So it's basically kind of well-known, let's say. But for this company particularly, it was just a new product. No, even the founders at the beginning, they didn't know how the product would look like. So they have the pictures and what we're going to do with that. So basically, the first version of this database was basically we are storing data there without any kind of organization, let's say. So we are just storing data. Everything was a JSON. So that's the whole picture of how this first version of the database, how it started. And it's important to point that because one of the issues that we were facing is that, well, since we don't know how to store stuff, let's put everything in a JSON and store in the database. And everything was a JSON, a lot of fields in JSON. We were using Postgres, which has support for JSON fields, but it's at the end of the day, it's a relational database. It's not a NoSQL database. So it has, of course, some optimizations for that, but it's not the ideal word to store JSON in a SQL database. Of course, that the company was small, the database was small, so it wasn't so difficult. So basically, the company wasn't perceiving how this could become an issue in the future, because if you're storing JSONs, you cannot relate that to other fields. So and the lookup, it's really hard to look up fields. You need to do that in the application's end, which is really more boilerplate to the application at the end of the day, right? So other problems that we found, again, lack of proper relationships. Because of that, we couldn't extract insights from the data. It's hard to manage this kind of stuff. Data using wrong data types. So, physicists storing data, they don't care for that. Let's store everything as a string. But it kills a lot of cool things when you're using a relational database, like arranging queries, for example. So if everything is a string, so you kill this kind of feature that you have in the database. So wrong data types, it was one of the issues. Other issues that we found that are a lot of services, hidden services, accessing the database and doing raw SQL. Despite we are using Django, they are using raw SQL to access the data, which is pretty bad because you cannot enforce business logic to this read and write on the database, right? So this is an issue. Thanks God we are using a relational database, so at some level, due to the ACD properties of the database, we didn't get it didn't get too ugly, let's say. So because the database itself could manage some sort of consistency in the data. So why it was challenging? Mainly because we need to get these JSON fields, break that, see, not even JSON, but other fields, we need to get this data and break that and store in other tables. We also need to create this relationship that was basically it didn't exist at that time. So it was really a trick to do that. And on top of that, of course, we want to make the data cleaning, standardization of the data. And also we had some time constraints because we want to release a new version of this system to our customers. And having the old database, it was also preventing some really cool features. So it was, we also have the time constraints to build that. So the deadline was July of 2024, but of course, everyone here that managed a project, usually you have to deliver that much earlier in order to test, in order to have the proper evaluation of everything's working. So the deadline was July 2024, but for ours, deadline was much earlier than that. So first attempt, just I don't like to reinvent the wheel. I'm not that kind of person that want to, oh, we have an issue here, let's develop a new network protocol. So I'm not that person. I usually try to see if there is anything in the market, not in the market that, because startup, we don't have much money, so I was basically looking into open source projects, and also in our cloud provider, AWS, if we could see some out-of-the-box solutions or any project that could help me to manage this migration with the issues that we have at hand. And mainly of those out-of-the-box solutions, they were basically helping you to migrate from MySQL to Postgres, Postgres to whatever, so this kind of migration, right? So, and some sort of data cleaning, but not for complex scenarios like the one that I was at hand at that moment. My second attempt was, okay, no project out of the box, nothing, let's do a vanilla script. I will write the SQL commands, we'll get the data, fetch data, process that, store. Well, it was hell on earth, I can say, because I was starting to writing really complex SQL queries, and I'm not a database engineer, let's say, so a DBA, like in old times. But, and I probably wasn't writing the best queries in the world, but it was taking a lot of time. We had time constraints, so I realized that I was like spending a lot of time just writing the SQL queries, which wasn't good. So the final solution was basically, okay, so we are using Django in the old environment. We want to use Django in the new environment, the new version of this application. So why not use Django ORM? I know that ORM were not designed to this kind of task. So ORM is not, probably if you look to the Django documentation, which is pretty good, you won't see, oh, you can migrate databases using our ORM. You won't see that, believe me. So I know that it is not the main goal for this kind of tool. But at the end of the day, I don't need to worry about SQL statements. Django would manage that for me. Database connections, everything was there. And one thing that I like, I really enjoy object-oriented programming, make my life easier. I just do that once, and then I can expand the logic to other complex scenarios. So pretty nice. So I just realized that I had probably the solution for that issue that I was trying to solve, right? Just some, of course, that other minor issues were fun, but for me, the main two issues with this solution that I just realized, or mainly two, right? So the potential issues was everyone that worked with Django, if you didn't have any issue with the migration files, you are not using Django at your full experience, because migration files in Django can be really tricky to manage, and it's really easy to break stuff, and it's hard. So I was really concerned about that, because we were using like two databases with two Django instances, one instance doing read and write. So there is like really potential situation that could happen. So how we manage that? So we defined the source database, the old Django instance, as the source of truth. All migration files were being generated in that instance, no matter what. Oh, we're going to generate that, and then we copy that to the new instance. So we just said, okay, so this is our source of truth, no matter what. So this is the one way that we could manage any potential issues with that. The second issue, after copying the data, okay, so we're going to copy all the data to the new database, and then what? So we're still going to have some services using the old database. So we still have to keep the old database running at some sort of, at least at some level. and we need to copy that data over time. And the way that we realized to fix that is using Django signals. Django signals is basically an event thing on Django that everything that something happens, do other things. So it's just like an event thing on Django that you can programmatically do that. And but it wasn't for all the tables, just for the tables that needed near real-time data. And a cron job for the tables, minor tables that doesn't need this real-time thing. We use it Celery like a cron job to copy that data regularly. So that's the main two issues. Of course, much more than that, but those are my two, I think, the issues that were more complicated for us to solve. Implementation, first step. I created, of course, I didn't want those services reading and writing in our database using raw SQL. So my first step was, okay, so let's create some APIs. So why? Because we're going to be changing the schema, the database, everything was going to change. And if any service or any application was tightly coupled with this schema, with this data, it's going to break. So the first step was, okay, so let's create this abstraction layer of the API. So read and write are going to be through APIs. Didn't like too much, but that's the way it is. Let's do that. Second step, I think this was one of the most important steps. We got everything that was interested, that knew how the company should look like, the features, everything. We put in a room, and we start discussing how the database should look like, how the data should be going through from this table to that table, how we're going to split that, what's the correct data type for that. So we put everything in a room, everyone in a room, so we properly, it happens a really good planning for that migration, right? So, and it was really good because, of course, that during the implementation, you have some back and forth to fix some smaller thing, but I can say that the first version was pretty close to the final version that we had at the end of the migration process. So I think that it was really good having this, spending a lot of time planning before actually coding stuff. And then the third step was finally the implementation. I'm going to go through here just some parts of this logic and how we managed to do that. So the first part, easiest part, was to define some functions. I just put 4 of them. There are much more than that. That would be used to clean the data or standardize the data, let's say. So we basically converting string to datetime, string into integer, things like that, to uppercase. I created a bunch of these functions to do the proper conversion of data to me. And I used that later in a dictionary that I'm going to show right now. So the idea was basically, I have a source table in our source database, and every record from this table would be moved to a specific table in the target database. This data could be moved to different tables, maybe sometimes with different formats. So this dictionary here basically defines that for me. Okay, so this dictionary, the bigger red square here, is saying, what is this saying? So on this table, which is the awesome table in our source database, the column type, so we have the column type over there, gonna be copied to the awesome target table in our destination database, and also to the cool target table in the target database. And here we have the mapping function. So this is where I just specify which function would be applied to that data before copying that to the database, to the target database. So with this dictionary, I could manage, okay, so I'm basically adding some logic to at the column level of this migration. So for every column, I was implementing this. So, and this dictionary was used to basically initiate the class that was actually handling the logic, right? So, and the smaller square here is just an example that when I'm specifying one of those functions here, I could just, okay, so for this case here, just convert that to the datetime process. So this is how we manage to this complexity of splitting data in several columns. So after that, I've just create some abstraction class. Basically, this class defines the main methods that would be used to copy the data and also update the data. So we need to not only copy the entire data so we have a table here, empty tables here, and then we can just copy the entire table. But we also need to update the table, right? So we need to do this kind of not only copy the entire table, but also once that I copied, I need to also update when something happens, when new data arrive. So this class here basically defines the foundation of the migration class, the migration logic. And using that abstraction, I created other classes to manage this migration, right? So soon I realized also that there are some simpler cases. Let's say. So the simpler cases, I would define like the cases where we are just copying the data as is. So we have the table A here, table A in the target database. We are just copying the data from here to here without any complex logic. So this is the simplest case scenario. And it's just a matter I wrote some pads here, but actually there was code here to copy the data, so just to fit in the slide. But basically, I just created some awesome migration class over there that are inheriting this simple table migration, initialize that, and just run the command that everything was run for the simple case scenarios. For complex scenarios, the idea was pretty similar, but I was just overriding those classes here when I needed to for the complex and the more fancy logic that I need in that time. Regarding some the migration performance for those who like this kind of information, like I said in the beginning, the database is not that big. We are receiving more data right now from other data providers, new cameras, and everything like that. So the database is increasing in size. But I would tell that this solution wouldn't fit for every scenario, so it's not a panacea, let's say. But it was fair for our database size. And of course, there are some optimizations that you can try. In our case, the main optimizations that I had was I was able to cache some queries. So I noticed that some tables are really being used for a lot of time. So for those tables, I was just caching the result and using that over and over again. So I don't need to actually query the database for those cases. And those simple cases that I mentioned, since we don't have any relationship to build, anything like that, was pretty easy parallelizing that scenario. So we could speed up a lot using those two main optimizations, right? So, and the main reason that I don't think it's probably the performance would be good for huge database because we have a for there for loop. It's a sequential loop, and sometimes data, so when you have to create these relationships, you need to do that in order. So you need to first create the data in one table, and then we create the other, and then we create the relationship. So sometimes it's just it is what it is. You cannot parallelize stuff, so you have to handle this sequentially, and that's the way. And we implemented that as a Django management command, so it's not a view, anything like that. So it's just a Python management command that Django provided for us, so we could run the code in a CLI per se, let's say. And I implement some other stuff to keep tracking of the migration process. One of them is this status command line, parameter. So here, just the source table, when it was last updated, and the last record that was updated. So with that, I could basically, if I have to update the table, so there is new records, it's just a matter to track that. So it's just this is just to, when was the last time that we migrate, that we copied this data from this table? So it's just using this command, so you would be able to see how the migration was going and when it happened and how the situation, right? So this is just an example. So next steps for this, of course, we want to get rid of all the database. Right now, we still using part of that, like I mentioned, but I can say that we're almost fully away from that, the first version of the database. And one thing that I think that we, on the roadmap, would be great to break this Django monolith into smaller services. Currently, we have just this huge database. Everyone is using that. Would be nice to have a proper database for each team, so everything can manage their own database, whatever they want. And also, with these new tables with proper relationships, everything in place, would be much easier to build analytics on that data and also build data pipelines in order to have a better, let's say, a better data in our database to be used for the customers. So this is what I want to show you. A lot of things happening in this migration. Of course, I have only 30 minutes, so I'll just show to you guys the most interesting part of that. Feel free to ask me questions, and those are my contacts, and thank you very much for having me. Appreciate it.
Thank you very much. Thank you very much. We have time for one question, if anyone wants to ask anything. Sure.
Just wondering, with your migrations, did you look at tying the migration of each field to the actual field definition in the model, so that then that knows which field validator type to look up?
How do I map the fields to one model to the other model? That's the question? Yep.
So in the big dictionary that you had there, you seem to be listing the mapping function just by hand. And I'm wondering if you could look at the actual model, look at the field that you're, let's say, the creator that field, that's a date time. Yeah. We need to now use the convert string to date time function.
I started this path as well. Thank you for the question, because it was something that I would like to make things more like because Django has this property that, so you can go to the model and see, what's this field model? So what's this type? So it can just convert. But turns out that when you go to that path, I was almost like in this second attempt here. I was spending a lot of time like, how Django do, because I've been using Django for a fair time right now, but this is not something that you do all the time. So you have to go to the documentations, and soon I realized, okay, so I'm doing, and then at the end of the day, we are not using, like I said, it's a simple database. at the end of the day, we are using just a simpler, we're not using any kind of fancy data type. And so that's the main reason that let's do that by hand. It's easier, and that's it. The only thing that I use Django for that is that when you see this dictionary here, there's the name of the table. For that, in the class, when I use a constructor to create the classes. So I grab that, the name of the column, the name of the table, and I convert that. So I use some Django functions to grab the Django model. So that's I use that because it's more readable. Oh, yeah, this is the class. This is the table, so it's easier than the model, I thought. Thank you.
Cool. Thank you very much, Arthur.
Thank you.
And here is a mug as a thank you.
Oh, thank you very much. Thank you.